All right, in our video today, we're going to talk about the concept of net present value. Now, so far you understand the idea of present value. So let's review, what is that? Well, every time we have a value in the future, like let's say I have to invest in a new piece of machinery. If it cost me, let's say $40,000 today, then the present value of that is still $40,000. However, if in year one that machinery is able to help me earn, let's say $2,000, then that helps me pay for that machinery. But today, if I've got to wait a year to earn $2,000, it's worth less to me today. And so year two's money, let's say it's $10,000. Well, it's not worth $10,000 to me today. I have to wait 2 years to get it. So it's worth less again. So net present value, it takes the concept of present value and it says, let's apply it to this deal where I have to pay money up front. That's a cost. And then every year I bring in money. But I have to keep calculating what it's worth every year. So Excel does all of that calculation for you in one step. It's called net present value. Along with that is a term called internal rate of return. That means that the money comes back over time to us and we don't say it's worth the same. It's got a rate. Well, internal rate of return tells you what your rate is of that whole scenario. So in this video, we're going to go over an example of net present value, looking at purchasing or building some grain bins where we can store our corn crop or store other people's crops, and hopefully that helps generate some money for us. The question is it worth building the bins? And so if we know what it costs, and then we're going to look, we have to look into the future and see what we think we might earn for some window of time. And then we can calculate if it was a good idea or a bad idea to move forward. Let's take a look at an example. All right, so I have an example built for you in Excel. Again, this is a grain bin potential idea to try to build some storage bins. We maybe could use them for our own crop, or really we may use them to store other people's crop and help earn money that way. So what we've looked at is the information. First of all is rate. So I do know my money can be used in other places. So the question is, what do I want this investment to earn me at minimum? And the rate I have in here is 6%. We always have to have some kind of a rate, any time value money calculation. We also need some dollars, and the dollars for this problem are going to be in several types. The first type is, what do you have to pay up front today? So in my formula here, or my Excel file, I've put in the cost of today is $850,000. Now, so we've got rate and we've got dollars. Remember, we also need time. So I've placed time into a table to lay this out for us. The time is, first of all, today. That's time value 0. But time value of 1 and 2 and 3 and 4 means that in our years, we're going to hopefully generate some income. Now you can see I also placed the annual values right here. So what I did for the first one was I just pushed equals and then put a negative sign right there and then selected what it cost me. The reason why is because that's an outflow of money to me. Well, you can see in year one, my estimate is I will lose $25,000 on this. Probably paying somebody to manage it. It will bring in a little bit of crop, but we're not going to be able to make any money in the first year. But in year two, we start bringing in some people to store product. And it looks like we're, got cost, of course. We're only making about $1,500. But in year three, we're estimating our business will grow, and we're going to keep growing all the way until about year 11. And it looks like in year 11, we're deciding that that's the flattening off of our income, because in year 13, 14, and 15, we're probably having to start doing some pretty major repairs to fix things up. And so we're going to actually be able to not earn quite as much. So again, time value of money needs a rate. We got it. Time value of money needs money. We've got it. And time value of money needs time. And we've also got that. All right, now what I've done here is just calculated the present value of each of these decisions. Now this would be a very long way to do this, but it is an example of what we've been looking at. So if I pay $850,000 up front, that's going to be a negative $850,000 in present value because it's today. Remember, time value 0. But in year one, if I lose $25,000, well, I got to wait a year to lose that. So actually, that's only like losing $23,000 today. Now, next year in two, I make $1,500, but really today, that's only worth $1,300. And so you can see I keep going all the way through. Now, how are these calculations done? If I double click on this cell, you can see all I did was just do a simple equal present value. And then I need some information. G6 is the rate. I put a dollar symbol in front of the 6, so when I copied it to all the other years, it did not move. But I've got rate. A11 would be time. That's year 2. Every time I move down, I get 3 and 4 and 5. So this is year 2 discount. And then C11 is the future value, which I have right there. So every time I move this formula down, it gives me an answer for that. If I jump way down here to year 13, we're making, or year 12, we're making $300,000. Really, that's only worth $158 to me today. As you get way out in the future of any investment, it has a larger impact on the value today. And so you can see that $60,000 up here, $65,000, it was worth 50 grand to us. But if I've got to wait to get all the way down to 15 years, it's only worth 25 to me. So as you move out into the future, these values become less and less important to you today. And that's the concept of time value of money. All right, well, I need to ignore this gray column. Don't let that confuse you. I just did them individually one at a time. Actually, the point for you to learn about is now something called net present value, NPV. Well, what it does is exactly what it does. It says, what's the net of all these present values? Well, I've already added them all up. Really, this grain bin is worth about $85,000 to me today. Well, it cost me $850,000, but I've already taken that out, so it's worth an additional $85,000. However, this is a lot of work to do and not really the right way to go. When you're looking at a bunch of future payments and a cost today, net present value is the calculation. So here we go. Let's calculate it. Lots of ways to get here. I'm going to press this little FX function in Excel, and it's going to bring over here. I'm going to type in NPV, and it gives me the formula. I double click on it, and here's the formula builder. All right, rate. What is that? Well, rate is going to be the 6%. So I'm requiring this investment to earn me 6%. Well, what about the values? All right, well, the values are going to be, again, don't use this gray column. Those are the bunch of present values I calculated. This is what I know. What I know is in year one. Now I'm going to start right here at year one. Why didn't I start at time value 0? Because it does not need to be discounted. It's already there. So net present value asks you to start at year one. What are you going to maybe get back? In this case, I'm going to lose money, but move down. I just keep highlighting to 3, 4, 5, all the way out to 15. Now, so really what I needed was I needed rate, I needed value. I'm going to go to the end of my formula and hit plus and just add that $850,000 I had to pay up front. So I've got all of my income potentials coming in. I've got my rate to discount them. Then I just add what my upfront investment cost is, and I hit enter, and that gives me the $85,722. The same thing I found when I added them up here in this formula. All right, but done a lot faster. So net present value is going to be the present value of all the years of potential income, and then you add to that the cost of today. And the net, if it's positive, this is a good decision. So that's what we would have there as an answer. Now, what about internal rate of return, IRR? Well, what that is that it's trying to look at, well, whatever you've paid up front, is it worth it to get all of these back? Well, we kind of already know the answer is yes. Remember, we tried to discount it at 6%. So what is it actually earning? That's the question. So what we do is, again, same thing, go to the formula builder, IRR, and hit double click here. And then it asks us, all right, what are the values? There's really nothing here. So what we do is we start with what we paid up front, which is going to be typically a negative number because we paid it. And then it's going to say, well, then next one is going to be your one. And then we move through all of these. And when we hit enter there, we'll see that it is earning 7%. Increase the decimals a little bit. It's earning 7.04%. Now we know that it's earning more than our rate of 6% because this is positive. So what is IRR? It's telling us this again, this is a good decision, but it's actually telling us this is our earnings. This is what we will be earning. All right, now the reason why we have this in Excel is because we don't know all these answers to be completely firm. So once we've built this, now I have the decision tool I need. So for example, what if we decided that actually it's going to cost us a whole lot more than this to get this done? Maybe it's going to be more like $950,000. Well, if I hit enter there, you can see that that starts to make this a bad decision. Now, we kind of already knew this. We had $83,000 in value. I added 100 to it, paid up front. So that lets us know that this is probably going to be bad. Well, how bad is it? Well, it looks like it's negative. That's a problem. We're earning 5.84% on our earnings. We needed 6. That's why that's negative. So we see this as a problem. So what if we go back and say, you know what, $850,000 is the kind of bins we need to build, but our incomes aren't right. We're not really going to be able to do as well as we thought. So because we're going to do a smaller set of bins, maybe we should adjust our periods here. Well, let's say we're going to probably lose the same amount in the first couple of years, but we don't think we're going to get as aggressive. So let's go at $100,000 is our estimate. We're not going to make that jump like we thought. 175,000 is maybe, if I type in the numbers right. Oops, that's still not right. So there we go. We're going to go at $175,000 is our top. There's no way we can get this amount done. In fact, we're going to start slowing down here. And we don't think it'll be that low there. Let's say that we feel like we can maintain that kind of a push there. Well, once we've adjusted that, you can quickly see it's still not working out. We're only earning 5%. If we want 6% on our money, this is not going to work. Well, maybe 6% on our money is not respectable. Let's say 5% is what we want. We already know the answer here. The internal rate of return tells us we're earning 5.1%. If I change this to 5, you can see it starts to show that, okay, this could be a good decision. So net present value is a great way, an easy way to calculate the present value of these varying payments per year. And we can go ahead and get it all in one calculation. So let's say that this was your requirement, 6% is what we want, the negative values are there. What would be a way we could get this done? Well, one of the ways would be is to not pay all the money up front. It might cost $850,000 today, but what if we borrowed the money? Well, our investment's earning us 5%. If we're able to borrow it, let's say 3%, well, we know we're earning more. So what we can do is say that we'll, again, to be quick about it, we'll just say we're going to put down $200,000 up front. So it's only going to cost us really today $200,000 to get this done. Now that jumps it way up. All of a sudden there's a good decision, it looks like. Now I'm going to pay interest and a payment every year, but interest is what's going to cost me the money. So I am going to lower all of these, but if I'm borrowing that money at 3%, I can guarantee you this will all still be very positive. So this is really why a lot of investments are done with borrowed money, because the upfront cost today, it's nice not to borrow the money, but the upfront cost today makes a likely good decision look bad because it's too much money up front. But if we borrow and we can earn the amount of money we need that, and then borrow at a much lower cost, then that's what makes the idea of borrowing work out. So for example, again today, $200,000 is really what I got to put up front. This gets to be a very lucrative decision as long as I can get a borrowing rate that is way less than what I'm requiring my investment to earn. If I can get that done, then it's going to end up with about a positive return and a good positive net value across time. This is net present value. Hope this video helps explain it to you. Now, try it yourself using these values or, of course, the homework. Thanks.